Dear students, today we are going to learn Chapter 1 in iOS number systems. I am going to tell you about the number systems in a most scientific manner so that the whole core concept of this chapter can be completed within 5 minutes. So, as you can see here, when we talk about number system, we will start from natural numbers. So natural numbers are all the numbers like 1, 2, 3, 4, which we use for counting. Once you add number 0, it becomes whole number. And once you add all the negative numbers to this, like minus 1, minus 2, minus 3, minus 4, that becomes integers. And if we include all the fractions also like 1 by 2, 3 by 4, etc., then it becomes rational number. So that's all for rational numbers. It means natural number, add 0 becomes whole number, add all the negative numbers becomes integer, and add all the fractions, then you get rational numbers. After that, there are irrational numbers. What are irrational numbers? Irrational numbers like root 2, root 3, root 5, pi, etc. We'll talk more about this in the coming slides. So if we include rational numbers and irrational numbers, we get real numbers. Let us look into little more detail. So what are rational numbers? Again, rational numbers can be expressed as fractions of integers like p by q, where q is not equal to 0. And it can be written in a standard form p and q, so that there is no common factor other than 1, then it is called a standard form. Then irrational number cannot be expressed as fraction of integers. Rounding off rational numbers or irrational numbers. So if we want to round off a number to some given number of decimal places, we observe the next digit in the decimal part of the number. If digit is less than 5, we ignore it and state the answer without it. So just ignore the digit. Suppose you have decimal like 1.23459 and they are asking only first two numbers. So just take 1 point, then the first two digit and ignore all other. But if the digit is 5 or more than 5, then we add 1 to the preceding digit to get the required number up to desired number of decimal places. Let us see how we compare the rational numbers. To compare two rational numbers, follow any of these methods. So if two rational numbers to be compared have the same denominator, compare just numerators and then whatever is greater, that is the greater number. But if two rational numbers are having different denominators, make their denominators equal by taking their equivalent form and then compare the numerator of the resulting rational numbers. Also, you can compare by plotting two given rational numbers on number line. The greater rational numbers lies on the right of the other. Then let us see how we represent decimal numbers, the rational numbers. The decimal representation of rational numbers is either terminating or non-terminating, repeating. So that is the one of the other feature of rational number. Rounding off numbers to a given number of decimal places. This already I explained in previous slide, but here you can see like why we do it. We do it so that we can represent it into a certain number of decimal places. Because sometimes it is convenient to write the approximate value of a real number up to a desired number of decimal places. After that, irrational number. The decimal expression of an irrational number is neither terminating nor repeating. That is the main things you have to remember about irrational numbers. That's all. This covers all the core concepts.